Today we're talking about factoring the difference of two perfect squares. We're going to start off by multiplying these sets of binomials here. So here we're going to do double distributive. We're going to take x multiplied by x minus 2 plus 2 times x minus 2. And distribute the x, so we get x squared minus 2x. Distribute the 2, we get 2x minus 4. And notice that these middle two terms cancel each other out. So we just end up with x squared minus 4. Each of these are a perfect square. This is a perfect square variable. This is a perfect square. And if you take the square root of 4, you get 2. So we're going to look for a pattern here. Over here, we have 3a times 3a minus 4 plus 4 times 3a minus 4. Distribute the 3a, we get 9a squared minus 12a. Distribute the 4 plus 12a minus 16. And notice again that these two middle terms cancel each other out, and we're left with 9a squared minus 16. So again, we have two perfect squares here. 9a squared, if we were to take the square root, we would get 3a. And if we take the square root of 16, we would get 4 here and here. So here's our final answer for here. So we're going to go backwards. Excuse me. This is what we call the difference of two perfect squares because it's a perfect square for each of these and we're subtracting. So we're taking the difference. So we're just going to sort of generalize that here and go backwards. So we have two perfect squares, we're subtracting, so we're taking the difference. And if we're going to factor that, this is in the form of a squared minus b squared. We're going to figure out what the square root of a squared is. So the square root of a squared, which is really x squared, is x. And then we're going to take b squared, which is 25, and take the square root of that as well. And that's 5. So we're going to take the square root of a squared that goes here and here, and square root of b squared that goes here and here. One of them gets a plus, one of them gets a minus. So here's the general rule for factoring the difference of two perfect squares. When you have a binomial that's in this form, a squared minus b squared, you're going to put it in two sets of parentheses. Again, one of them gets a plus, one of them gets a minus. So let's take a look at an example here. So again, this is in the form of a squared minus b squared. So a squared is 25m squared. We're going to take the square root of both of those. And you can take the square root of 25 right in your calculator. That's going to be 5m. b squared is the second term here. That's 4. I'm going to take the square root of that and get 2. So I'm just going to put this into the parentheses. A goes in the first spot, here and here. B goes here and here. One of them gets a plus and one of them gets a minus. And that's it. So we're going to factor this one right here. Again, this is in the form of a squared minus b squared. A squared is 16r squared. We're going to take the square root of both sides and get a is equal to 4r. B squared is our second term here. That's 9. Take the square root of that. So b is 3. And we're just going to plug those into the parentheses here. So we're going to put a here and here. B here and here. One gets a plus, one gets a minus. Go ahead and try this one on your own, and we'll continue talking about this in class. See you then.